As humans, we may think that we are the strongest species on Earth. However, our senses are nothing compared to those found in the animal kingdom. Whether it be echolocation, sensors and whiskers, electroreceptors, or others, it seems that we are not the superior species we think we are. In this video, we will share senses that make bats, dolphins, whales, and jaguars, and sharks amazing animals.
Alrighty, so the animal that I chose was dolphins. Dolphins have very good vision, so they are able to see while they are in the water as well as when they come up to the surface. This good vision allows them to move freely in the water and it helps them avoid dangers, such as predators and even boats that are in the same water as they are. Dolphins have excellent hearing as well. They're able to hear frequencies that are at least 10 times what the best adult hearing can offer, which is pretty cool. The melon, which is located on top of their head, helps with hearing through a complex process of echolocation. They use their teeth as a type of antenna so they can receive information about incoming sounds. They can also use echolocation to help them successfully locate objects. They get information about the size and the shape of an object before they actually could see it through this process. Dolphins use echolocation to navigate and hunt, bouncing high-pitched sounds off of objects and listening for the echoes. Dolphins live in social groups up to 5 to several hundred. They use echolocation to find prey and often hunt together by surrounding a school of fish. Dolphins may also be able to use magnetic senses too. This allows them to use the magnetic field of Earth to help them stay orientated and for navigational purposes. It is possible that it plays a role in migration and helps them to identify where they should be. The overall sense of touch that dolphins experience is highly developed. This is due to the free nerve endings that are around the skin. The nerves seem to be more sensitive around the snout and the fins, but the entire body is very sensitive. This sense of touch could be why they are able to form bonds with the pods and with humans as well. They could feel a positive benefit and reduce stress to touch, just like humans experience. The human touch could be a positive stimulator and may explain why dolphins often do what humans request them to do. Did you know numerous of studies have found that dolphins are capable of performing complex tasks and appear to recognize themselves as individuals? For example, when you get up in the morning and look in the mirror, and you know that's you. You have a sense of that's you. They have a similar sense. They can look in a mirror and say, hey, that's me, which I think that's pretty darn adorable. It is also believed that dolphins' use of sonar also allows them to see through soft tissue in humans and one another, where the basics of our anatomy are not vastly dissimilar. Here is a little short video that I found to basically go over how dolphins use echolocation. It might be a little bit loud, but I hope you guys enjoy.
In a show about sound, you might wonder why I get to swim with these fun creatures, dolphins. Well, for one thing, dolphins have incredible hearing, much better than people do. But they can also use sound in an amazing way. Dolphins can actually use echoes to tell what's in the water around them. Can you hear the sounds the dolphins are making? When these sounds are sent out underwater, they bounce back off whatever they hit, like, say, a school of fish. By listening to the echoes, dolphins are able to tell exactly where the fish are and even what kind of fish they are. Now that's an incredible use of sound. Dolphins aren't the
Alright, for now we're going to stay on the topic of underwater, but this time we're going to be talking about sharks. Now, underwater, you know that it's really dark and murky, so you'd think sharks might have great vision. Well, there you would be wrong. To accommodate for the lack of vision underwater, sharks have a great sense of smell, but they also have two other senses that you might not know of. The first one is called the ampullae of Lorenzi, which these are special sensing organs called electroreceptors. And what that does is they sense the muscle movements of like a prey, which sends electrical signals that the ampullae receive, which is sent to the brain. And now we're gonna look at a picture. These right here, these little pores, those are the ampullae. Ampullae, however it's spelled. Let's go back to that first shark picture. There we go. And now we're going to talk about the lateral line, which is another thing the sharks have. It's somewhat similar to the ampullae, but it pretty much gives the ability to sense like pressure changes in the water caused by like currents hitting rocks or other animals, going in and out. But what it also does is it senses vibrations. So like when your heart beats, it sends out vibrations, which essentially a shark can hear your heartbeat because of the vibrations it gives off. And now I'm going to show you a drawn demonstration of what goes on there. See right here, there's a little shark right there. And this guy, his heart is beating super fast, as opposed to this guy. He's a little more calm. Now the shark is going to go after this guy because he can sense that his heart is beating a lot faster, and he's most likely panicking. So when an animal is panicking, it's a lot easier to, take down, if you will. So if you're ever underwater with a shark, then you should try to, keep yourself calm a little bit. Don't freak out. Even though there's a like 1,000-pound shark in front of you, just relax.
Since the ocean is dark and murky, whales' eyes are adapted to these conditions. Their eyes are flatter with less of a cornel curve, allowing as much light as possible to enter. The light is then reflected twice for maximum vision. With fewer cone cells, it enables the perception of colors. Whales also have an advanced sense of hearing. Whales are generally more adept at hearing low-frequency sounds. When whales make a sound, they emit anywhere from 20 to 200,000 hertz. This is quite remarkable because humans are only able to hear up to about 20,000 hertz. Now we'll be going on to jaguars and their senses on how they hunt. This is a short clip of a jaguar getting ready to go in for a killing bite. As you can see, it's sensing on where exactly it wants to kill. Once it judges where it wants to bite, it goes in. It's quite remarkable if you ask me. Jaguars can see 6 times better than humans at night or during darker conditions due to a layer of tissue in the back of their eyes that reflect light. Jaguars have whiskers that perform a touch sense. They have whiskers on their cheeks, above their eyes, and on their muzzle. Projecting part of the face, usually around nose and mouth, is where the muzzle is located. When they capture their prey, the muzzle whiskers are spread like a circular net in front of their mouth so that the jaguar can judge exactly where their prey is for a killing bite. The jaguar usually employs the deep throat bite, but it sometimes uses a killing method that is unique amongst cats. They pierce directly through the temporal bones of the prey's skull between its ears, ultimately piercing the brain of its prey.
Different kinds of bats in the world.
We have all heard the phrase, "you are blind as a bat." However, that phrase actually makes no sense because it's just not true. In fact, bats very much can see. It's just the way in which they do this that makes them remarkable. Bats are nocturnal animals that need to go out at night to hunt. In order to do this, they use the same system used by dolphins called echolocation. Here is a clip of a bat's call. At the end, we can hear quicker clicking, which is when a bat probably knows he's close to an insect and needs more accuracy to catch the prey. Therefore, he needs the call responses to come back quicker. Humans are not able to hear a bat's call without proper equipment. That is because the sound is at a too high frequency for humans to hear. Human hearing ranges from 20 Hz to 20 kHz when compared to bats who can hear frequencies of up to 110 kHz in frequency. There are also insects such as moths, beetles, and crickets who can hear these noises made by bats, which in turn allows them to run away. Some of these insects then make the decision to run away or not, which if they don't have time, they will begin flying in zigzags to disrupt the bats. Scientists have studied this bat technology and in turn it has helped them create the sonar and radar navigation systems which are used by the military and researchers. Radars, for example, use the electromagnetic waves to determine the location of an object like planes. Another interesting fact is that although all bats use echolocation, depending on the bat species, they are able to tailor the frequency ranges they emit for their particular environment. Scientists then use this difference in frequency calls to identify the different bat species. Thank you for watching our video, and I hope you have learned a lot about different amazing animals out there. I bet you don't feel so superior anymore, right?